In this video, I'll talk about how to take an ER model over to a relational model. So this is actually so simple that it can be automated. There's only a couple places where you have to make an actual decision, otherwise it's just rule-based. So starting with the entities. Regular entities in ER model become tables in the relational model, and their attributes become attributes of the table. Simple attributes become attributes. Composite attributes are broken up into their components, and each component becomes an attribute of the new table. And the key attribute of the entity becomes the primary key of the table. Also, derived attributes, if you've decided to store them in your database, even though they can be calculated, then they just become regular attributes of the tables. Also, a weak entity becomes a table, and its simple, composite, and derived attributes become regular attributes. However, its key is a little different, so we'll talk about that when we talk about identifying relationships. Okay, regular relationships, non-identifying relationships, let's see how they work. So a one-to-many relationship. In order to represent that in the relational model, you make the primary key from the one side as a foreign key in the table on the N side of the relationship. And that's because when you have a one-to-many relationship going this way, right? It means you have a one-to-one relationship going in the other direction. And that means that for everything on this N side, there's only one on the other side. So we can just put the foreign key in there to represent the partner row from the other table. In a one-to-one relationship, well, it doesn't really matter. So you take the primary key from one table and you put it as a foreign key in the other table to create the reference from the one to the other. Since it's one-to-one in both directions, you just put the reference on the side that you want it on, but there's no difference. Now, a many-to-many relationship is more complicated because there's neither side. You can't put the foreign key on either of them because both sides have a many relationship. So they can refer to many rows of the other table. So you can't just put one foreign key. In that case, you have to make a new table to kind of map between the two. So you take the primary key from one side and the primary key from the other side, and together those two foreign keys become the primary key of this new table. So you have to make a new table for a many-to-many relationship. Now, what do you do if you have attributes on a relationship? The attributes go with the foreign key. So whichever side you move the foreign key to, then the attributes go with it. In a many-to-many relationship, of course, you have the new table, so all the relationship attributes go in this new table. So now let's talk about identifying relationships and their corresponding weak entities. So if you have a one-to-many identifying relationship, which is the most common, then you do the same thing as with the regular one-to-many relationships. The primary key from the one side or the identifying side becomes a foreign key in the weak side or the end side. However, because this is an identifying relationship, then on the weak side, the new foreign key plus the partial key together become the primary key of that table. And that makes sense, right? Because it's an identifying relationship, and we said all along when it was in the ER model that the weak entity takes its identity from the other entity, the one that's identifying it. So clearly that key from that table should become part of the primary key of the new weak table. So if it's 1 to n, it must have a partial key, but we remember with a one-to-one identifying relationship, there's not necessarily any partial key. And so in that case, the primary key from the identifying side goes and becomes the foreign key in the weak table and the primary key of the weak table as well. And again, the attributes are going to move over to the weak entity. In both of these cases, they're going to move to the weak entity. And always in a one-to-one relationship situation, you can put the two tables together because, of course, there's only one of each of them. So if they're small, you can just combine them together. Now, we didn't talk about multi-valued attributes. As you remember, multi-valued attributes are not allowed in the relational model. An attribute value in the relational model is a single atomic value. So for multi-valued attributes, you're going to have to make a new table to hold all those values. So if we imagine in our ER model, we have some entity with its ID, and one multi-valued attribute that we had a lot of times was the phone number. So in order to handle that, we're going to make a special table to list all of the phone numbers of every one of whatever these things are. So this new table takes the key attribute from the original entity and the value of this multi-valued attribute, and together they form the primary key of this table, because obviously you're going to, it's multi-valued, so for the same whatever the ID is, maybe this is person number 12, they're going to have two phone numbers. So for this to be unique, it has to be the combination of the two in order that these will be unique, because many IDs will be there. All right, the last thing I'll talk about is how to handle inheritance relationships. So this is the only place where you actually need to think about what you want to do. The rest kind of just follow some rules. In this case, you can look at what to do with the super and subclasses depending on how complicated they are. So one way is to model each one of them as a table. And when you do that, of course, there will be a one-to-one identifying relationship from the superclass to the subclass. And then you can just follow the rules of one-to-one identifying relationships. But another way you can do it is you might get rid of the superclass. Maybe the superclass had just 2 attributes in it. So you can make tables for each of the subclasses and just give them the identity and the 1 or 2 attributes from the superclass, and then don't give that superclass its own table. Another choice is, again, if this super and subclass relationship isn't so complicated, like the things don't differ so much from one another, you might put all of them together into one class, and then you create some attributes to specify the type, maybe a type field or Boolean attributes that distinguish between, is this one of these subclass or one of those subclass. So that's another choice, is put them all together into one table. So that's the only place where you have to think about what to do. You make a decision. In all the other cases, what happens is well defined. And that's why we'll see in the next videos, I will do the mapping using the modeling tool from MySQL Workbench, and it just does these rules for you automatically. Okay.